Alright guys, so we're adding and subtracting rational expressions. And as I do, adding and subtracting fractions was never my strong suit. I was like multiplying, it seemed easier. Now let's start off. Let's do a refresher course. What would be 1/2 plus 1/3? Well, what do we have to have the same to add fractions? The common denominator. That's right. So I'm going to multiply this by 3 over 3. Please don't say multiply by 3 because we're actually multiplying by 1. Dressed up as 3 over 3. And this guy I got to multiply by 2 over 2. What are we doing essentially? We're looking at the bottoms and saying, well, what does this guy need and this guy need so they can look identical? Well, this guy needs to be times by 3, and this guy needs to be times by 2. And what you do at the bottom, you must do the top. Leaving me with 3, 6, plus 2, 6, for a grand total of 5, 6. We could do that. We could do that in our sleep. Let's see if we can do it with radical. So what if I had 1 over x plus 1 plus 1 over x plus 2? Remember that these guys, like marrying somebody, you got to take the whole thing with them. You got to marry them and you got to get their family with them. So you can't just do multiply by 1 over here because that would stay the same. And multiplying by 2 over here doesn't really get us this. So what do we need to multiply each side by? Well, I'm thinking on this side, I need to multiply by what? I need an x plus 2 over x plus 2. Right? Because that's really just a fancy 1. Alright, so what does this guy need? This guy needs an x plus 1 over an x plus 1. Alright. Pretty simple. Leaves me with x plus 2 over my new denominator. One times x plus 1 is x plus 1. Over my new denominator. And just like up here when I did 3 plus 2 equals 5, doing the same exact thing. X plus 2 plus x plus 1. All over my denominator. Cool. X plus x is 2x. 1 plus 2 is 3. Voila. All done. Because there's nothing I can factor out of this guy. 2x plus 3 is, that's factored. There's nothing we can do. Okay, great. What about if I asked you what's 2/3 plus 1/6? Well, how do we make our denominators look the same? Well, you're going to look at this and say, well, gosh, it just needs to be multiplied by 2, right? Because this is really, what does this really mean? This is really 3 times 2. So in order for these to look the same, I just have to multiply this first guy by 2. Okay? Which gives me 4, 6, plus 1, 6, for a grand total of 5, 6. Great. Awesome. Let's see an example with a radical. Let's say I had, let's make it interesting. 2x plus x squared, or 2x squared plus x, plus x over x plus 1. Alright, when you're doing something like this, your first step should be, just like it was with multiplication, factor. Can you factor this down? Let's see. I think I can factor this guy and make him a little bit, pull something out of him. What are you going to pull out of him? Pull out an x. No big deal, right? We're still going to add x over x plus 1. Alright. So what do I need to make this guy look like this guy? Thinking I need an x. So if I want an x, I got to multiply both the top and the bottom by x. Gives me 2 over x times x plus 1. Actually, I wish I had a copy of the table close with this before. Plus x squared over x times x plus 1. Do they look the same? Absolutely. Can we add them? Absolutely. So, remember, when you add the denominator, it stays the same. It's x times x plus 1. When you add the numerator, there we go. Numerator, you just add them together. Can we simplify this? Not so much. So, that's your answer. That's it. That is the big scariness that is adding radicals. You want to try subtraction real quick? Just as easy, I promise. The difference being, with subtraction, you gotta watch out for that distribution on your second thing. Alright, same concept. What if I had 1 over, oh gosh, 1 over 6 plus, no, we're going to minus, alright, 1 over 15. Well, we got to find something that is common between all of them. So it's 1 over 2 times 3 and 1 over 3 times 5. What does this guy need to look like this? Well, it needs a 5. So we're going to multiply by 5 over 5. What's this guy need to look like this? It needs a 2. So we're going to multiply by 2 over 2. Gives me 5 over, I'm pretty sure that's 30, minus 2 over 30. Cool. 5 minus 2 is 3. When we subtract, our denominator stays the same. Gives me 30. Ah, cool, I can reduce. They both have a 3 in them, leaves me with 1 over 10. Alright. Same thing. Let's do x minus 3 squared over 2 minus 3. No, not 3. Yeah, why not? 3. Minus 3 over x squared minus 3. Alright. First step, factor. Do me a favor. You see that x minus 3 squared? Write it out. You guys constantly forget that means 2 of these. Does not mean x squared minus 9. Don't do that to me. It's x minus 3 times x minus 3. Alright, minus. Oh, sorry. This should be 9. My bad. X squared minus 9. Anybody know what that equals? What's the rule that we're going to be looking at? The difference of squares. This is a perfect square, and this is a perfect square. That means we can use different squares. We end up with x minus 3 times x plus 3. What does this guy need to look like this guy? Well, he's already got that x minus 3. So the thing that he needs is that x plus 3. So we're going to multiply him by x plus 3 over x plus 3. Alright. Well, now what does that guy need? He's already got the x minus 3 and the x plus 3. Good, right? No, not so much. How many x minus 3s does this guy have? He's got 2 of them. So in order to add them, this guy has to have 2 of them as well. Alright. Multiply this all out. This is 2 times x plus 3 minus all over. So, minus 3 times x minus 3 all over da-da-da-da-da, da-da-da-da-da, da-da-da-da-da. Alright, so, our denominators are the same. We can subtract or add or do whatever we want. Try it. So from all over there, I'm going to come down here because I don't think the camera goes all the way up there. So we've got 2x plus 3 all over, 2 times the quantity of x plus 3 minus 3 times the quantity of x minus 3 all over x minus 3 squared times x minus x plus 3. I got lazy, sorry. Alright. Please remember that this is a negative 3, and we need to distribute it to everything inside. Leaving us with a grand total of 2x times x plus 2 times 3, 6. Minus 3 times x is minus 3x. Minus 3 times minus 3 is positive 9. Okay? All over x minus 3 squared times x plus 3 equals 2x minus x. 2x minus 3x is minus x. 6 plus 9 plus 15 all over x minus 3 squared times x plus 3. Since I can't simplify that, I'm done. And that is adding and subtracting with radicals.